Okay, so to sum up, the MLA is the complete touring sound reinforcement system solution. It achieves unprecedented even balance right from switch on, raises the bar in terms of venue to venue and gig to gig consistency and repeatability. Artistic changes to balance at the mix position or elsewhere translate directly and accurately throughout the audience. Automatic intelligent optimization software eliminates trial and error in system setup. And exceptional high power density means tighter truck pack for higher SPL compared to other systems. So this is enabling us to deliver our goal of making every seat in the house the best seat in the house. Thank you. So I'll be happy to take any questions on...
First standard format question for all speaker people. Okay, so your speakers all suspend one from the other.
Correct,
cabinet.
yeah.
Therefore, a cabinet is an accessory under lifting gear. Do you provide a certificate of conformity to conform with lifting gear?
Oh yes, we do. Yeah. So we've what we do is we go for the most stringent lifting gear standard in the world, which is BGVC1, and so we design all of our flyware to be compliant with that standard. And the optimization software does the calculations on the fly to actually prove that each array falls within the safety criteria of BGVC1.
Nicely answered.
Hello. You said in the beginning that this is not a line array. That's
Correct.
true because you are treating each element differently. But
Yes.
As a question, you were referring to that you are very good in the difficult acoustic spaces,
Yeah.
as you can control more the vertical coverage.
Yeah.
But what about the horizontal coverage? That's where you usually have the hard walls.
The horizontal
get
coverage
problems, yeah.
is fixed, but the step back from this. The thing with the MLA is because it's got constant directivity horns, you notice that the mid and the HF are next to each other rather than being combined. It means that the horizontal dispersion is really, really well behaved off axis. It basically just keeps on getting quieter as you go around rather than getting lumpy and bumpy in its frequency response. And what we find is that with any fixed horizontal dispersion product, just so long as your off-axis performance is very, very consistently, smoothly dropping in level as you move away from the forward axis, then its interaction with acoustic spaces is actually surprisingly benign.
How far you are controlling your directivity to the same Q? How to the...
Well, in terms of it's a 90-degree dispersion,
Yeah.
so it's minus 6 dB there.
Yeah.
But if you go out to past 120 degrees, then you're talking minus 10. But the important thing is the frequency response is still flat down to about 300 hertz, where the pattern control starts to
then
be lost.
you're getting on. Yeah.
Yeah.
Not being a sound person at all, how does the system know all of this?
How does
the system know all of this? You're saying you can cut out a balcony that's got more reflection, all this sort of stuff.
What you do is you put the geometry of the room into the optimization software, and you tell it, for example...
Can you show us the software?
Yes, I can. I'll get that booting up while we ask some more questions. It does take a little while.
So the geometry of the room is taking a CAD drawing or something and putting it in? Or?
Typically what you do is you use a laser tape measure and then you just shoot the room with that. You can sketch in the geometry very quickly and then take those rough dimensions and make them more accurate once you've actually got distances and angles with a laser tape measure. So you just do a 2D shell, place the array. You also put where the stage is as well, because we treat the stage as a very sort of heavily biased avoid area for any sound coming from the array. So one of the great deliverables with the MLA system for things like orchestral work is that there's virtually no problems with feedback on stage due to all the open mics, because there's very little sound actually going down towards the performers.
All right. Thank you.
Yeah, that's going to take about 2 minutes to start up for the first time, the optimization software.
You said this has got the amplifiers built and the DSP built into
Yes,
it.
yeah.
How much does it weigh?
It weighs 87.5 kilos. So as far as a line array, well, as far as a touring loudspeaker goes of this capability, it's actually still very light, even though it's got all of the amplifiers built in. Typically, cabinets of that output level, you're talking 100 kilos plus without the amplifiers in. But we've used a lot of lightweight materials inside. We've used neodymium drivers throughout, for example, and we've really just taken every great pain to get as much weight out of the system as possible.
You're still talking coming on to 2 tons for a 24-box hang now, aren't
Yes, yeah.
So you talked about getting the data into the software.
Yeah.
I guess you're still fundamentally at the mercy of the person with the laser tape measure.
Correct, yes.
And you're not using, there's no acoustic measurements that form part of that analysis. It's literally the geometry of the room.
It is, yes. I think what we find is that if you try and close the loop and put the forward output of the speaker system in, then measuring the forward output in a real situation is so fraught with error that it could easily throw out the optimization process. So we've concentrated on generating a really, really accurate acoustic model of what the array is doing. So we know when the sound field from the array is instant on the audience surface, we know within plus or minus 1 dB what that sound pressure level and frequency response is going to be. And we spent a lot of time researching how to do that and found out some very interesting things about effects that weren't being taken into account by the industry, which we had to take into account in order to get that level of accuracy. Basically, when you put one loudspeaker next to another one, even if one of them isn't turned on, it affects the frequency response and the directivity quite considerably. And if you've got a cabinet in the middle of a long array, it can give you an error in the mid-range frequencies of up to about 8 dB. So if your computer model can't take that into account, then it's basically wrong. You can't do what we're doing with that level of inaccuracy. So we had to figure out how to actually quantify that for any given shape and size of array.
And you talked about horizontal dispersion earlier. Do you have isobar plots to back that up?
We do. I've not got any on my laptop, I'll have to say, but we do have off-axis performance curves that we've taken in the lab which show how smooth it is off-axis.
And one more question. Is this been deployed? Is it out on the road? It is
actually, yes.
Heard?
We've got... well, there was a system out on a tour in Germany for about the last 3 months. We've now got another...
Is that with somebody we'd have heard of?
No, it isn't, but... because I hadn't heard of them either. But apparently they're very big in Germany. But we've got a system out in the US which is doing a national tour with the Zac Brown Band. Now, I'd not heard of them, but apparently in the US this is a Grammy-winning artist who is selling out shows night after night after night kind of thing in big sheds and arenas. So he's not big to us, but in America he's a rising star.
Does your software take into account also the acoustical parameters, whether it is a hardcore or tape syncing or software?
It's purely a direct sound field calculator. If we try to put reflections into it, then the mathematical problem grows to such a size that you can't actually do the calculations in a reasonable amount of time. Typically, to do a full optimization of a large array in a room like Earls Court 1 will take about 15 minutes, which is fast enough to use at a show, because what you do is you come in, measure the room, put that into the software, it tells you the splay angles within 2 minutes, then you're rigging the system, meanwhile it's calculating the DSP coefficients. When you're done rigging the system, the computer's done with calculating the DSP coefficients and you're ready to squirt them in and switch it on. And typically what we're finding is when companies use the system, or whether we do sort of demos with it, because we're getting this incredibly consistent balance across the whole of the floor right from switch on, people are sort of amazed that that's it, you're done really. You might just do a little bit of EQ just to set it to sort of your tonal balance preference, but you're pretty much done from switching it on. So there's not this usual fight with the sound system, in the 1 or possibly 2 hours that you're given before you have to hand over to the sound engineer. There's not this fight to try and get the system to sometimes just work acceptably at all, or maybe to a certain level of proficiency. The system is sort of 98% tuned right out of the box on switch on, and then the system tech can spend his time then actually making it sound brilliant, rather than having to fight with it just to make it acceptable.